Ever wondered why certain diesel engines become legends while others fade into obscurity? Why some trucks from the 90s are worth more today than when they were new? What if I told you there's an engine so bulletproof that farmers still hunt for 30-year-old examples and truckers refuse to sell them even with 1,000,000 miles on the odometer? Today we're counting down 20 shocking secrets about the Cummins 12-valve 6BT that even die-hard diesel fans might not know. From its unexpected origins to the underground modifications that can double its power, these revelations will change how you see this mechanical marvel. So buckle up, hit that like button if you're ready for some diesel education, and let's dive into the ironclad world of the most legendary engine ever bolted into a pickup truck. Number 20. The 6BT wasn't designed for pickups. It started life in agricultural and industrial machines before Dodge adopted it in 1989. Here's something that'll blow your mind. The engine that saved Dodge's truck division, it was never meant for trucks at all, not even close. The Cummins 6BT started its life powering grain elevators, irrigation pumps, and industrial generators. Think about that for a second. This wasn't some purpose-built pickup engine developed in a Detroit lab. It was a workhorse designed to run 24/7 in brutal conditions where failure meant crops dying or factories shutting down. Cummins had been building these inline-six diesels for years before anyone thought about stuffing one under a pickup hood. The B-Series platform dated back to 1984, and it was engineered for one thing only: survival. These engines lived in environments where maintenance meant maybe an oil change once a year if you remembered, where operators expected them to start in -40-degree weather or 120-degree heat without complaint. So when Dodge came knocking in the late 80s, desperate for something to compete with GM and Ford's new diesels, Cummins basically said here, "Take our industrial engine, we'll make it fit." And that's exactly what they did. They took an engine designed to power sawmills and adapted it for the road. The result? Absolute overkill for a pickup truck, which is exactly why it became legendary. Number 19. 6BT means six-cylinder, B-Series, turbocharged, a name as simple and tough as the engine itself. You know what's refreshing about old-school engineering? They didn't need fancy marketing names, no EcoBoost or Power Stroke nonsense. Just 6BT, that's it. 6 cylinders, B-Series platform, turbocharged, done. The name tells you exactly what you're getting, nothing more, nothing less. The B-Series designation actually meant something significant in Cummins' lineup. It represented their mid-range engine family, positioned between the smaller A-Series and the massive C-Series used in big rigs. The B indicated a specific bore size and architecture that Cummins had been perfecting since the early 80s. This wasn't their biggest engine, it wasn't their most powerful, but it was their sweet spot for reliability. That T for turbocharged? In 1989, that was still special. Most pickup diesels were naturally aspirated slugs. The turbo transformed this agricultural engine into something that could actually move a 3,000-pound truck with authority. Simple designation, legendary results. Sometimes the best things don't need clever names. Number 18. It used a cast iron block and head with 7 huge main bearings, making the bottom end nearly indestructible. Let's talk about why these engines refuse to die. 7 main bearings, 7. Most automotive engines use 5. High-performance engines might use 5 really good ones. The 6BT, 7 massive bearings supporting that crankshaft like it's carrying nuclear secrets. Each bearing surface was larger than what you'd find in engines with twice the displacement. But here's the really shocking part. Both the block and the head were cast iron. In an era when everyone was moving to aluminum for weight savings, Cummins basically said, weight savings are for quitters. The cast iron head alone weighed more than entire modern engines. This wasn't just old-fashioned thinking, though. It was brilliant. Cast iron expands and contracts at the same rate, whether it's the block or the head. No blown head, gaskets from differential expansion, no warped heads from overheating. The bottom end was so overbuilt that tuners regularly triple the stock horsepower without touching the internals. We're talking about engines making 800 horsepower on factory rods and pistons. Try that with any modern diesel. Actually don't. You'll scatter engine parts across 3 counties. Number 17. The famous Bosch P7100 P-pump was fully mechanical, delivering precise fuel control with no electronics to fail. The P7100 injection pump is probably the most legendary fuel system ever created. No computers, no sensors, no electronic nonsense, just pure mechanical precision that would make a Swiss watchmaker weep. This German-engineered masterpiece could deliver fuel with timing accuracy measured in fractions of a degree, all through mechanical governors, springs, and weights. Here's what made it special. The P-pump used a camshaft inside the pump housing with individual plungers for each cylinder. As the shaft rotated, these plungers would compress fuel to insane pressures, over 18,000 psi, and send it to the injectors at exactly the right moment. The governor mechanism used centrifugal weights and springs to control fuel delivery based on engine speed. It sounds simple. It wasn't. This was mechanical engineering at its absolute peak. But the real magic? Adjustability. 3 screws could transform your grocery-getting farm truck into a tire-shredding monster. The star wheel adjusted. Maximum fuel. The AFC screw-controlled air-fuel ratio under boost. The governor springs determined how quickly fuel ramped up. Diesel mechanics became underground legends just by knowing which screws to turn and how far to turn them. Number 16. Stock power was modest, 160 to 215 HP, but torque exceeded 400 lb-ft, dwarfing rival gas engines. Okay, let's address the elephant in the room. 200 horsepower from a 5.9-liter engine isn't impressive. Even in 1989, that was just adequate. But horsepower was never the point. Torque was the point, and this thing had torque for days. 400 pound-feet at 1,400 RPM. That's barely above idle. Gas engines were making half that at twice the engine speed. To understand why this mattered, you need to understand how people actually used trucks back then. Nobody cared about 0 to 60 times. They cared about pulling a 30-foot gooseneck loaded with cattle up a 7% grade without downshifting. They cared about maintaining highway speeds with a bed full of feed corn. The 12-valve delivered its torque right where you needed it, down low where real work happens. Ford's gas V8 made similar horsepower, but needed 4,000 RPM to do it. The Cummins was already pulling stumps at engine speeds where gas motors were still clearing their throats. This wasn't about racing, it was about working. And for work, torque beats horsepower every single time. Number 15. Turning a few screws on the P-pump could unleash 100-plus extra horsepower without internal mods. This is where things get crazy. Remember those 3 screws I mentioned? Turns out they were basically magical horsepower screws. A stock 12-valve making 200 horses could easily hit 300 with nothing but screwdriver work. No parts, no labor, just knowledge, and maybe 15 minutes in your driveway. The star wheel inside the P-pump controlled maximum fuel delivery. From the factory, it was set conservative. Way conservative. Backing it out added fuel. More fuel meant more power. Simple as that. The AFC housing could be modified to allow boost to build before adding fuel, eliminating the famous black smoke cloud. Governor springs determined how aggressively the pump delivered that fuel. Stiffer springs meant harder acceleration. But here's the insane part. The engine could handle it, all of it. That extra 100 horsepower didn't stress the bottom end at all. Guys were daily driving 300 horsepower 12 valves for hundreds of thousands of miles. Try adding 50% more power to any modern engine with just tuning. You'll need new internals, new turbo, new everything. The 12-valve just laughed and asked for more. Number 14, The engine's timing gears, not chains or belts, made it nearly maintenance-free and perfect for high-mileage haulers. While everyone else was using rubber belts that needed replacing every 60,000 miles, Cummins went with gear drive, actual metal gears. No stretch, no wear, no catastrophic failure, leaving you stranded. These gears would outlast the truck, the owner, and probably civilization itself. The gear train wasn't just driving the camshaft either. It powered the injection pump, the vacuum pump, the power steering pump, everything, all meshing perfectly, all the time, forever. You could run a 12-valve for 500,000 miles and those gears would still mesh like new. No timing chain stretch affecting performance, no belt teeth shearing off and destroying your engine. This is why you see million-mile 12 valves still running. There's literally nothing to maintain in the valve train, no adjustment needed, no parts to replace. The only wear items were the injectors and maybe the lift pump. Everything else just kept working. Modern engines, with their complex variable valve timing and chain tensioners, seem like Rube Goldberg machines by comparison. Number 13. Cummins engineers balanced the inline-six perfectly, reducing vibration even with massive rotating weight. An inline-six diesel should shake like a paint mixer. All those massive pistons and rods reciprocating in a row should create harmonics that'd rattle your teeth out. But the 12-valve was smooth, eerily smooth for something with pistons the size of coffee cans. How? Perfect primary and secondary balance, that's how. Cummins engineers understood that inline sixes have natural balance advantages, but only if you get the counterweighting exactly right. They spent countless hours perfecting the crankshaft counterweights, balancing not just the reciprocating mass, but also the rotating assembly. The result was an engine that idled like a sewing machine, despite having enough rotating mass to generate its own gravitational field. This smoothness wasn't just about comfort. It meant less stress on engine mounts, less wear on accessories, and less driver fatigue on long hauls. Truckers could drive 18 hours straight without the constant vibration wearing them down. It's one of those engineering achievements that nobody notices because it works so well. You only appreciate it when you drive something else and realize your spine doesn't have to feel like a tuning fork. Number 12. Dodge trucks gained instant credibility with the 6BT. Sales tripled within 2 years of its debut. Before 1989, Dodge trucks were a joke. Sorry, but it's true. They had a 7% market share and were circling the drain. Dealers couldn't give them away. Then they dropped the Cummins bomb and everything changed overnight. Sales didn't just improve, they exploded, tripled in 24 months. From also-ran to serious contender just like that. The transformation was shocking to everyone, especially Ford and GM. Suddenly, construction sites that had been all blue oval and bow tie had Dodge trucks showing up. Farmers who'd been loyal to other brands for generations were trading in for Ram Cummins trucks. The diesel option alone was outselling entire model lines from competitors. But here's the really interesting part. The Cummins didn't just boost diesel sales. It created a halo effect for the entire Ram truck line. Even gas-powered Dodges started selling better because the brand suddenly had credibility. The Cummins partnership literally saved Dodge's truck division from extinction. Without it, Ram trucks probably wouldn't exist today. Number 11. Early versions were non-intercooled. The 1991.5 update added an air-to-air intercooler for lower exhaust temps and more power. The first 12 valves from 89 to 91 were running naked. No intercooler, just hot compressed air straight from the turbo into the engine. Exhaust temps would hit 1,400 degrees if you looked at the throttle wrong. But even without an intercooler, they were making 400 pound-feet of torque and embarrassing big blocks. Then, mid-year 1991, Cummins added an intercooler. Not some dinky little thing either. A proper air-to-air unit that dropped intake temps by 200 degrees. Suddenly you had denser air, more oxygen, and the ability to add more fuel without melting pistons. Power jumped to 190 horses. Torque stayed huge but came on smoother. EGTs dropped by 300 degrees under load. The intercooled engines became the sweet spot for modifications. That cooler charge air meant you could push more boost, add more fuel, and make serious power without turning your exhaust manifold into lava. It's why 91.5 to 93 engines command premium prices today. They had all the mechanical simplicity of the early engines, plus the thermal efficiency to handle real power. Number 10. Its simple design made it immune to the electronic failures and emissions issues that plagued later diesels. No EGR, no DPF, no DEF, no computer controlling 17 different parameters just to start the engine. The 12-valve was mechanical simplicity in its purest form. If it had fuel, air, and compression, it ran. Period. End of story. No check engine lights because there was no engine computer to check. Think about modern diesels for a second. Exhaust gas recirculation systems that clog with soot. Diesel particulate filters that require 500-degree regeneration cycles. DEF systems that freeze in winter and leave you stranded. Thousands of dollars in emissions equipment that does nothing but create problems and kill fuel economy. The 12-valve had none of that garbage. This is why they're still coveted 30 years later. You can park a 12-valve for 5 years, dump fresh diesel in the tank, cycle the glow plugs, and it'll fire right up. Try that with a modern diesel. You'll need a laptop, diagnostic software, and probably a dealer visit just to clear the fault. Codes. The 12-valve's simplicity wasn't primitive. It was perfect. Number 9. Many 12 valves have logged over 1 million miles on original internals with only oil changes and injectors. 1 million miles. Let that sink in. That's 40 trips around the Earth's equator. That's driving to the moon and back twice. On original pistons, rods, and bearings. We're not talking about rebuilt engines here. We're talking about engines that have never been apart except for maybe a head gasket and injectors. There's a guy in Kentucky with 1.6 million on his 95. Original bottom end. A farmer in Iowa just crossed 1.4 million hauling grain. These aren't internet rumors. These are documented, verified million-milers that just keep accumulating miles like it's nothing. The secret? Those 7 main bearings, that overbuilt bottom end, and mechanical injection that doesn't stress components with radical timing changes. Modern engines are lucky to see 300,000 before major work. The 12-valve treats 1 million miles like a warm-up lap. Oil analysis on these high milers shows bearing wear that would be acceptable at 100,000 miles on other engines. It's not uncommon to find original crosshatch marks still visible in the cylinders at 500,000 miles. Number 8. Turbo boost was a conservative 18 to 20 psi stock, but enthusiasts routinely double that on factory head bolts. 20 psi from the factory. That's nothing. That's what modern gas engines run. The 12-valve's whole-set turbo was loafing at stock boost levels. It could easily handle 35 psi all day long, 40 psi with supporting mods. Some maniacs run 50+ on stock head gaskets. The cast iron head and block just laugh at boost pressure that would split aluminum engines like ripe melons. The stock head gasket was a multi-layer steel unit that could handle way more than factory boost. The head bolts were massive and could clamp that iron head down tight enough to contain nuclear explosions. Combined with the matched expansion rates of the iron block and head, you had a sealing system that could handle double the factory boost without flinching. But here's the really wild part. The rotating assembly didn't care about the extra boost. Those forged rods and cast crank were designed for industrial applications where failure wasn't an option. 40 psi just meant more power. The only limit was how much heat you wanted to generate and how much fuel the P-pump could flow. Number 7. The 6BT's torque output destroyed early Dodge automatics. Transmissions became the weak link, not the engine. 400 pound-feet of torque at barely above idle. The A518 automatics behind the early 12 valves didn't stand a chance. They were designed for gas engines making half that torque. The 12 valve would eat them for breakfast. First gear would strip. Torque converters would balloon. Valve bodies would crack. The 47RH wasn't much better. It became a running joke in the diesel community. Buy a Cummins, budget for a transmission rebuild, or 3. Guys were going through transmissions annually while their engines didn't even notice. The torque came on so hard and so low that it would shock load the drivetrain like hitting it with a sledgehammer. Even the 5 speeds had issues with input shafts twisting. This is why built transmissions became such big business in the diesel world. The engine was indestructible, but everything behind it was made of glass. Modern built 47RE and 48RE transmissions can finally handle what the 12-valve dishes out. It only took the aftermarket 20 years to catch up to what Cummins built in 1989. Number 6, Cummins offered marine, industrial, and generator versions of the 6BT, often running 24/7 for decades. Here's something truck guys don't realize. While your 12-valve was pulling trailers, identical engines were powering fishing boats in Alaska, running generator sets in hospitals, and pumping water in third-world countries. These weren't different engines. Same block, same internals, same bulletproof design, just different accessories and ratings. Marine versions were particularly impressive. Constant load, 3,000 RPM, salt air trying to destroy everything metal. These engines would run 20,000 hours between rebuilds. That's over 2 years of continuous operation. Generator sets were even more brutal. Constant load, constant speed, zero maintenance for months at a time. They just ran. The industrial versions proved what the platform could really handle. Some were rated at 300 horsepower from the factory for continuous duty, not peak power. Continuous. All day, everyday power. This is why tuners knew they could safely extract so much from the pickup versions. Cummins had already proven the bottom end could take it. Number 5. Its mechanical injection lets it run on almost any diesel-based fuel, even heating oil or kerosene in emergencies. The P7100 pump didn't care what you fed it as long as it was slippery and flammable. Diesel, biodiesel, heating oil, kerosene, jet fuel, filtered waste vegetable oil, it would burn them all. No sensors to confuse, no computers to throw codes, just mechanical injection doing what it does. Atomizing fuel and sending it into the combustion chamber. This flexibility made the 12-valve legendary in rural areas. Farmers could run off-road diesel and save the road tax. In emergencies, you could dump 5 gallons of heating oil in the tank and keep moving. Try that with a modern common rail system. The high-pressure pump would grenade in minutes. The injectors would clog. The computer would have a nervous breakdown. Preppers love 12 valves for this reason. In a real emergency, when supply chains break down, you can run these engines on almost anything. Petroleum-based. Mix some 2-stroke oil with kerosene for lubricity, and you've got emergency fuel. The engine might smoke more and make less power, but it'll run, and in a crisis, running beats walking every time. Number 4. The 12-valve became the go-to swap for older Fords and Chevys, giving rise to the Cummins and Cummins cults. Blasphemy. That's what Ford and Chevy guys called it at first. Then they drove one. Suddenly, everybody wanted 12-valve power in their preferred truck body. The Cummins movement, a Ford body with a Cummins heart, exploded in the early 2000s. Cummins swaps into square body, Chevys created the Cummins cult. Brand loyalty went out the window when 400 pound-feet of torque was on the table. The swap wasn't even that difficult. The 12-valve was completely mechanical, so no computer integration needed. Adapt the motor mounts, fab up some intercooler piping, figure out the transmission. and you're done. Guys were putting 12 valves in everything. Ford Super Duties, OBS Chevys, even Jeep Wranglers. The engine didn't care what badge was on the grill. These swaps proved something important. The 12 valves appeal transcended brand loyalty. It was simply the best diesel engine available to regular people. Ford's IDI was agricultural, but weak. The 6.5 Detroit was fragile. The Duramax didn't exist yet. If you wanted reliable diesel power, the 12-valve was it. Period. Number 3. Its distinct diesel clatter and turbo whistle became part of 1990s truck culture and still define diesel nostalgia. That sound. You know exactly what I'm talking about, the mechanical clatter at idle that sounded like a bucket of bolts in a paint shaker. The whistle of the whole-set turbo spooling up, the bark when you lifted off throttle. These weren't just noises, they were the soundtrack of an era. Every farm, construction site, and truck pull in the 90s had that sound. Modern diesels are whisper quiet. They have to be. Noise regulations and customer expectations killed the classic diesel sound. But the 12-valve didn't care about being refined. It announced its presence with authority. You heard a 12-valve coming from a mile away. That wasn't a bug. It was a feature. It was honest. That mechanical injection clatter told you everything was working. Each injector firing sounded like a tiny hammer blow. The turbo whistle meant boost was building. These sounds became so iconic that modern diesel owners spend thousands trying to recreate them. Straight pipes, deleted mufflers, aftermarket turbos, all chasing that classic 12-valve sound that came free from the factory. Number 2, farmers, truckers, and preppers prize it because it can run indefinitely without electronics or sensors. EMP-proof, grid-independent, apocalypse ready. The 12-valve doesn't need civilization to function. No computers means no vulnerability to electromagnetic pulses. No sensors means nothing to fail when supply chains collapse. As long as you can find diesel, or something close to diesel, this engine will run until the sun burns out. Farmers keep old 12-valve trucks specifically as backup power sources. Weld a PTO on the transmission, and you've got a mobile generator that can power grain dryers, irrigation pumps, or your entire homestead. Truckers keep them because they can fix them roadside with basic tools. No laptop needed, no dealer visits required, just mechanical know-how and maybe some baling wire. The prepper community has elevated the 12-valve to mythical status. It's the ultimate bug-out vehicle engine. No GPS tracking, no electronic nannies, no remote shutdown capability, just pure mechanical freedom. In a world increasingly dependent on fragile electronics and complex systems, the 12-valve stands alone as the last truly independent engine. Number 1. The 12-valve's reputation for million-mile durability made it the gold standard. Newer diesels are faster, but none last longer. Here's the truth nobody wants to admit. We've gone backwards. Modern diesels make more power, burn cleaner, and run quieter. But they don't last like a 12-valve. They can't. All those electronics, emission systems, and high-pressure fuel systems are ticking time bombs. A CP4 pump failure on a modern diesel can cost $15,000. A P-pump might need a rebuild at 500,000 miles for $800. The 12-valve set a standard that nothing has matched since. It proved that a diesel engine could be powerful, reliable, and simple all at once. Every diesel that came after has been chasing that formula and failing. They add power but lose reliability. They add technology but lose durability. They add refinement but lose character. 30 years later, clean low-mileage 12-valves sell for more than new trucks. That's not nostalgia talking, that's the market recognizing true value. These engines will outlive their second and third owners. They'll still be running when current diesels are crushed and recycled. The 12-valve didn't just set the gold standard for diesel durability, it is the gold standard. Forever. And there you have it. That's 20 shocking secrets about the legendary Cummins 12-valve 6BT. Which of these facts surprised you the most? Do you have any 12-valve stories of your own? Drop them in the comments below. We read every single one. If you enjoyed this deep dive into diesel history, smash that like button and subscribe for more content about the engines that changed the automotive world. Hit the notification bell so you don't miss our next video about the trucks that refuse to die. Until next time, keep those turbos spooling and those P-pumps clicking.